By the way, these are all in what's called vertex form, and I do want us to write down what vertex form actually is. So off to the left, I want you to go ahead and right near example 1, we have to do some setup here. So I want you to write vertex form. And I'm going to have you write this down as well. F of x is equal to a, and then parentheses, x minus h squared plus k. Now, we did see this in chapter 1. We know that a, the value of a, describes whether or not the function faces up or down, right? If a is positive, that parabola is going to open upward. If a is negative, it's going to open upside down. We saw that in chapter 1. If the value of a gets larger, the graph gets narrower. If the value of a becomes a fraction, the graph gets wider. That's the difference between a vertical stretch and a vertical compression or a vertical shrink. If we have a value of h, that's moving left or right. If we have a value of k, that's moving up or down. We saw that in chapter 1 as well. The other thing that we need to mention here, though, is specifically the actual values of h and k. So the vertex itself is the point hk. So while h and k describe the horizontal and the vertical shifts, the value, specifically the point, the number for h and the number for k, is the vertex of that parabola. It's the middle of the parabola. So let's go ahead and take a look here at our first example. And we'll go ahead and describe this together. We'll go ahead and put it on a graph and figure out what's going on. You can use your calculator to go ahead and figure out some points. But we also, let's just go ahead and start off with our vertex. Graph your vertex first. So what is the value of h in this particular graph? What is it? 3, yeah. So I'm going to go ahead and circle 3 in red. I'm going to put an arrow to that and call that h. And then what's our value of k? Anybody know that one? That's our value of a. So a is 0.4. I don't think I have a different color here, but I think I need green or something like that. But a is 0.4. I'll just go ahead and do this and then say a. A is 0.4. H is 3. What about k? If it said +1, then yes. 0. Yeah, it's 0. K is 0. If there isn't a number after your parentheses, then k is going to be 0. Over here, k is 2. So if you want to on this one, you can say, you can draw an arrow to that one and say, there's k. K is 2. But over here, k equals 0 because there's nothing after the parentheses. We can go and identify h and a over here as well. So what does h equal in b? Which one is h? H is 1. Good. Now, if the parentheses said +1, what would h be equal to? If this is a +1 in here, what would h equal? H is actually +1 right now. It'd be -1, yeah. Remember when we got things inside parentheses, it's kind of like the opposite of what you'd expected, and that has to do with the function over here. The actual formula part of it has a minus already. And so if something is subtracting in the parentheses, then the number itself is positive. If something is adding in the parentheses, then the number itself is negative. That's something that we've talked about in chapter 1, but it's been a little while. All right, A is 3 on this one. Here's A. A equals 3. All right, now we're going to just go ahead and do some graphing here. So the vertex of this particular graph here what's the vertex of this graph here? HK is the vertex and H is 3 and K is 0, where's the vertex? At 3, 0, exactly. So the vertex here, so just put V for vertex and then we'll do 3 zeros. All right. Now, we don't have any X or Y axes in here yet, so we're going to go ahead and have to set that up. And you can do them right in the middle. That's fine. So we can just say, here's our Y axis straight through the middle, vertically. There's Y. And then X, we can just go horizontally straight through as well. It doesn't need to be perfect. Just make it as good as you can. So there's X and Y. And our vertex is at the point 3, 0. So that's going to be 1, 2, 3 zeros right here. That's the middle of our vertex. Let's Now, if we were to graph the parent function here, and I'm going to go ahead and do that real quick as well. I'm going to graph the parent function, just y equals x squared, just because it gives us a little bit more information. So we got, I'll do this one in black. This is kind of like what we saw in chapter 1, where we had two parabolas on the same graph. So there's, that's y equals x squared right there. Now, this particular function has been moved 3 to the right. You can see that because the middle of the graph is no longer in the middle. It's now moved over 3 to the right. The vertex is at 3, 0 because HK was 3 and 0. Now, is this going to be a vertical stretch or a vertical compression based on that number there? It's a compression. Yeah, it's less than 1. It's a vertical compression with a value less than 1. Now, the issue with this is that we still have a few things that we need to figure out in terms of putting points on the graph, but thankfully, it's not going to take us too long to figure that out. Okay, so what we need to figure out now is we got to get a couple other points on this graph. So if you want to, if you got your graphing calculator in front of you, that's great. If you don't, that's okay too. I'll just go ahead and remind you an easier way to get points on a graph here. We could plug in values of X and figure out values of Y. That's certainly something we could do, but I'm just going to suggest that we go in and graph this real quick. So we got 0.4 and then parentheses X minus 3, close it up, square it, and that's it. So that's our function right there. And if we go to the graph, we can see what it looks like. And you'll see we've got our vertex exactly where we need it to be, and it's moved over to the right, and it's a wider, more compressed version. But if we want actual values of X and Y, remember, you can actually go to the table on your graphing calculator to figure out where those points exist. So if you hit the second button and then hit graph again, that'll take you to the table. And right now we have this point right here. We have the point 3, 0. So if we go back 1 to 2, that'll put us at 0.4. So if we go back to 2 and 0.4, that's a little bit less than half, so that's about right there. And you'll notice that 4 also has a y value of 0.4 because points on a parabola are always going to be symmetrical on either side of the vertex. And then if we go to 1, you can see we've got 1.6. So 1.6 will be about right there. And then you got another point over here at 5, 1.6, because again, same height on opposite sides of the vertex. And we'll get a couple more on the left here. So if we go to 0, we got 3.6. That's almost at 4. About right there. And if we do one more, let's see, 6.4. Actually, I don't think we have enough height for that. So we'll just go ahead and get those points on there. Now, if you wanted to, if you take a value of X, so if you plug in 3 for X right here, you get 0 for Y. If you plug in 2 for X right here, 2 minus 3 is -1. -1 squared is 1. 1 times 0.4 is 0.4. So you can plug in values of X and get values of Y. Or if you want to, you can just go ahead and use the table on these calculators. That's fine. Anyway, that's our graph. Now, a couple things we need to do. It says describe the transformations and then graph the function. So we've got our parent function, y equals x squared, or f of x equals x squared. We have our new function, g of x equals 0.4 times x minus 3 squared. And now we have to describe the transformations. So there's two things happening here. We have ourselves a vertical shrink or a vertical compression by a factor of 0.4. So I'm going to say vertical shrink by factor of 0.4, because that's our value of A. And we also have a horizontal shift right 3. Or you could say a shift of right 3 units, horizontal shift of 3 units. I wrote horizontal shift and right. It kind of, that's a little redundant. But this is all stuff that we've seen. It's kind of nice actually starting off with a little bit of review. Hopefully this is starting to kind of ring some bells that we saw from chapter 1. All right. Take a look at B, and I'm gonna say 2 minutes to try to work out B. So try part B on this one. And see what you can come up with on part B. And then we'll move on to example 2 after that. You do not have to graph the parent function if you don't want to. You only need to graph g of x. All right, if you want to take a look up here, this is what I came up with on mine. We've got ourselves a vertex at 1, 2. We have a vertical stretch by a factor of 3 because A is 3. We have a shift to the right of 1 unit because H equals 1. And we have a shift of up 2 units because K equals 2. This one still faces up though, because A was still positive. If you figure out more points than the ones on there, you probably realize pretty quickly that they wouldn't have fit on the graph anyway if you're counting by 1. Because if you go to -1 or if you go to 3, the Y value is 14. So you'd have to change your scale altogether if you wanted to fit more points on there. So I just went ahead and put my X, Y in the middle. All right. Is this looking familiar from chapter 1? Hopefully at this point, you're kind of maybe getting back into it a little bit. Okay. Now the next thing we're going to be talking about is from example 2. And there's a little bit of some notes that we need to talk about with before we get to example 2. So I'm going to go back to the notes over here. Got everything there. All right, we talked about example one already. This is what we were dealing with, the values of A, H, and K. So here's our, here we go. Here's our examples of those ones there, and moving on. Okay, example two. So key features here. If we're talking about a function here, f of x equals 2 times x minus 3 squared plus 4. We know that A is 2, H is 3, K is 4. So we're going to have a vertical stretch by a factor of 2. We're going to have a shift of left 3 or right 3 units. And we're going to have a shift of up 4 units with the vertex at 3, 4. And we can see that's right here, 3, 4. Now, what we need to talk about here is we're going to be talking about range. We're going to be talking about the domain. And we're going to be talking about the axis of symmetry. And because if you look at on your paper there, for example 2, it says identify the vertex, that's HK, the axis of symmetry, which we'll talk about, whether it's a minimum or a maximum. We'll talk about that as well. And then the domain and the range of the function. Now, we're not adding in much based on what we've already learned. Because we talked about domain, we talked about range, we know where the vertex is. So really the only two things we're going to be adding are the axis of symmetry and whether or not there's a maximum or a minimum. And I'll talk about what that means in a second. So we're not going to be writing our range like this. We'll just be writing it like we normally would. Y is greater than or equal to 4. We're not going to do the braces here either. So we don't need to worry about that. Now, we know that it's being stretched by a factor of 2. Now, wherever the x value is, you'll notice this 3 here, it says the axis of symmetry is x equals 3. Axis of symmetry, all that means is the middle of the graph, what's the x value? So basically it's just saying the x value of the vertex. Where is the middle of your graph on the x-axis? That's what the axis of symmetry is. So anytime you have your vertex and it asks you about an axis of symmetry, you're going to write x equals whatever the value, x value of the vertex. That's it. And that describes this dotted vertical line right here. That's the axis of symmetry. The other thing we need to talk about is the vertex a maximum or a minimum value? Now, if A is positive, think about it this way. If A is a positive number, it's a regular parabola, it opens up, which means that the bottom of the graph is the minimum. There is a bottom to this graph because it opens upward. Now, if it opened the other way, got my red pen here. If it opened the other way like this, that means that A is negative because now it's upside down. And if A is negative, the vertex then becomes a maximum value. So that's what we're talking about between maximums and minimums with our values of A. The value of A determines that. So a couple things I want you to write in on your notes off to the left. I'm going to fill some things in here. Get this working. There we go. Okay. So back to our notes off to the left here. We know our vertex is HK. And for the axis of symmetry, x equals h. If you want to write this as well, that's just the x value of the vertex. The x value of the vertex is the axis of symmetry. X equals whatever h is. If we're talking about a maximum or minimum, we can just say vertex is a maximum when A is less than 0. If A is negative, that means it's upside down, which means your vertex will be at the top, making it a maximum. It's the other way around if your vertex is a minimum. So vertex is a minimum when A is greater than 0. All right. So let's go ahead and check out example 2. So, yes.
Would A and B be examples of a minimum?
What's that?
Would A and B
A and B.
problem one?
Oh, problem 1. Yes, yes, great recalling there. So if we go back to, example 1 real quick, both vertexes here are minimum values because they're at the bottom of each parabola. A is positive, therefore the vertex would be a minimum. Yeah. However, on example 2, let's talk about this one real quick. Identify the vertex. So somebody tell me the vertex here of problem number 2. Actually, how about this? Let's write A equals, let's write H equals, and let's write K equals real quick, and then we'll figure out those things. So what's the value of A here? What is it? Wait, A. Yeah, what's A? A is -1, good. So our value of A is -1. That tells us quite a bit about this particular parabola. What's the value of H? It's a plus this time, -4, good. H is -4, and what's K? K is -5, good. All right, now, here's what I would strongly recommend doing. Either sketch the graph or look at it on your graphing calculator, see what it looks like. Now I'm just gonna do a very quick sketch of this because, so here's an X, here's a Y axis, X and Y axis right here. HK, where's my vertex at on this one? Yeah, so off to the side, I'm gonna say V, -4, -5. Now, if I have a vertex of -4, -5, that's gonna be somewhere down here, right? For -4, -5. Again, I'm not gonna put numbers on this. I just want to do a very brief sketch. The negative value of A means what about the direction of the parabola? It's facing upside down. Yeah. So I'm just gonna do a super quick sketch. And that quick sketch right there is gonna allow me to basically answer all the other questions. I don't need to know these numbers exactly. I just need to know this in generalities. And so giving us a general, very quick sketch of what's going on, we can now answer the rest of these. So where's our axis of symmetry? If the axis of symmetry is the X value of the vertex, and we're gonna write it X equals, what's our axis of symmetry gonna be? Yeah. So we're gonna write axis of symmetry, and then we're gonna say X equals -4. That's it. That's all you gotta do for that. On the graph, that's the middle of the parabola, which is basically that dotted line right there. X equals -4. Again, I don't have numbers over here. We don't need numbers over here. We're just doing a very brief sketch. Is the vertex, having this sketch is really going to be helping with the visual side of it. So is the vertex the top or the bottom point? It's the top, yeah. So we have a maximum. So the vertex is a maximum. So we're going to say max. So the vertex is at -4, -5. The axis of symmetry is X equals -4. The vertex is the top of the parabola, making it a maximum. And the last two things we need to do are state the domain and the range. Now, we've talked about domain quite a bit, but just as a reminder, domain are all the possible values of X. And if you recall, the domain for every single function is going to be the same. You better remember what it is. All real numbers. Good. So the domain is all real numbers. Remember, that's just that capital R with 2 vertical lines. That's our domain. The range, and actually I want you to write one more thing off to the left here. And I want you to write this. Range relates to the Y value of the vertex. The range relates to the Y value of the vertex. Now, I can't really tell you whether it's going to be greater than or equal to or less than or equal to just based off of the Y value. You have to take into consideration both the Y value and the value of A. Or more easily, just look at the sketch. But any single time you're talking about a range, it will relate directly to the y value of the vertex. So anytime you're going to state the range of a parabola, you can always start by saying r, and then you can do y, leave a gap, and then write the y value of the vertex, which is -5. And then we just have to figure out which inequality symbol needs to go in between these. And you can do that based on either the value of a, or the quick sketch, or a combination of the two. So take a look at the parabola here. Hi, May, we good? Hey, what's up? Take a look at the parabola. Are all the values of y, are they above or below the vertex point? They're below it. Yeah, they're underneath it. So because it's facing upside down, all the values of y are less than or equal to the y value of the vertex. If it faced up, it would be the opposite. It'd be greater than or equal to. All right. Now, here's a question for you. Think about this question for a second. Actually, before we move on, are there any questions about example 2? We're just adding a little bit each time. We're not doing, hopefully not doing too much. Next question here. In what order should you apply the transformations shown in this example? There's 3 transformations, right? We have a reflection across the x-axis because a is negative. That's our first reflection we've seen today. We've got a horizontal shift left 4 units, and we have a vertical shift of down 5 units. It says, in what order should you apply the transformations? You could certainly do that. Yeah. Yeah, I mean, honestly, if I were thinking about the parent function, I think about it in 2 different ways. So first of all, the answer is like, it doesn't really matter. However, think about it this way. So listen up. The way that I think about it is if I have the parent function to begin with, so if I just had f of x equals x squared, if I have that on there first, in my mind, I would probably do the reflection first, because it goes from facing up to facing down. So I would probably immediately think, okay, it's going to go upside down. And then once it goes upside down, I'm going to move it left 4 and then down 5. I would probably do it in that order that we wrote it here, if I have this function first. However, if I was graphing this from scratch, if that wasn't there to begin with, I would start with the vertex. Because this is in vertex form, so we know where the middle of the parabola is. So if I was starting from scratch, I would go left 4 and then down 5, put my point as my vertex, and then just draw it upside down after that. So to be honest, it doesn't really matter for this question here. As long as you apply all of the transformations, you're good. The order doesn't particularly matter. Okay. Now, the next question says, what is the equation of a parabola with a vertex of 1, -4, which passes through the point -2, -1? Write the equation in vertex form. So this one here, I don't have a whole lot in terms of like notes on the side to give you for this one. However, there is a process that we're going to use. So if you think about a vertex, what 2 variables do we use for a vertex? H and K, right? Yeah. So the 2 variables that we use for the vertex are H and K. So here's H, here's K. Now, another way to write f of x equals the vertex form here, f of x equals a times x minus h squared plus k, would be to write y equals a times, right? All that. So that's what I'm going to do. I'm going to write y equals. So for now, I just want you to write this down. Y equals A and then X minus H squared plus K, just like that. This is vertex form, but instead of f of X, we're using Y. And there's a good reason for that, because if you have the vertex HK and you have another point, what could we call those two? Any random point on a graph has what kind of coordinates? X and Y. So -2 can be X, -1 can be Y. Think about the variables in vertex form. How many variables are there total? We got Y, A, X, H, and K. How many total variables is that? 5. We got 5 total, right? How many of them can we put numbers in for? 4. Meaning we could solve for A. Because as long as you have, actually off to the left, let's see, write this down. You can write an equation in vertex form if you have A, H, and K. If you have A, H, and K, you can write an equation in vertex form. Everything that we've seen in vertex form so far has a value of A, has a value of H, has a value of K. X is always just the variable X, and then Y is always Y or f of X or g of X or whatever. But as long as you have A, H, and K, you can write something in vertex form. So right now, we have H and K, we have X and Y, we don't have A. We need A in order to write something in vertex form. So what we're going to do is some algebra. We're going to take our values of H, K, X, and Y, plug them in here, and we're going to solve for A, and then rewrite using A, H, and K. So, over to the left here, let's go ahead and drop some values in. So what does Y equal in this particular problem? -1. So we write -1 equals. We do not know what A is. So A is our variable that we're going to be solving for. In the parentheses, we have a value of X. What is it? -2. We also have a value of H. What is it? H is 1, yeah. However, we are going to write it using a minus because that's part of the form that we're using. So we're going to write -2 minus 1 and then squared. And then what's our value of K? -4, so we're going to write -4. All right. Now we have an algebra equation that we have to solve for. We're going to solve for A. So we're going to do the math inside here. -2 minus 1, what does that equal?
3.
-3, yeah. What's -3 squared? -3 times -3 is 9. And then A times 9 is 9A. So that's going to be -1 equals 9A minus 4. A times 9 is 9A, right? Now we got to solve for A here. So what's next? Plus 4 to each side, yeah. Add 4 to each side. What's -1 plus 4? 3. So 3 equals 9A. How do we get A by itself? Divide by 9. Yeah. So we got ourselves 3 equals 9A. We got to divide by 9 on both sides, right? What does A equal? 1/3. Good. So if we divide by 9 on each side, we get 3/9 equals A, but 3/9 is the same as 1/3. So A is equal to 1/3. All right, so we got one last thing we need to do real quick here. We need to write our answer in vertex form. So you're going to replace A with A. you're gonna replace 1 for h, and you're gonna replace -4 for k. All right, so our answer, here we go. We're gonna say y equals, or we can say f of x equals, let's go ahead and do that. F of x, because we want to make sure we're in function notation. F of x is equal to the value of a, which is 1/3, times x minus 1 squared minus 4. So when you write your final answer, don't use the number for x, don't use the number for y. The only reason we used the numbers for x and y was to figure out what a was. Once you have a, you're going to use a, h, and k in your answer. So our answer is here.
That's the answer.
That's the answer. Are there any questions about that? Because we're going to do it one more time on the next page. Here we go. So get that written down, and then we're going to flip it over. Anybody need more time on number 3? Okay, flip your page. Here we go. So example 4, it says the graph shows the height of a ball with respect to time. So height is on the y-axis, time is on the x-axis. What is the equation of the function? Write the equation in vertex form, then write it in standard form. Standard form is this one here, ax squared plus bx plus c. We'll do that in just a second. So this is the same type of question we just did, by the way. It just starts in graph form instead of variable form. So where's our vertex? 210. All right, so 210 would be hk. We also have an xy value right here at 0,4. So there's xy. So if we have our vertex form, that's going to be y equals a and then x minus h squared plus k. We're doing the exact same thing we just did. Plug in for hk, plug in for xy, solve for a. I'm going to try that one on your own this time. I'll plug these in with you, and then I'm going to have you solve and write it in vertex form on your own. Once you have vertex form, we'll go ahead and convert to standard form together. So let's see, y is 4. We don't know a, so that stays a. X is 0 minus h, so minus 2 squared, and then plus 10. All right. Does anybody have a value for a? -3/2, -3/2, or -1.5. Anybody get -1.5 instead? That's fine too. So Here it is. So solving for A, yeah, A is equal to -3/2 or -1.5. If you got -1.5, that works. You can use a decimal if it's a nice decimal. So our vertex form is going to be y equals -3/2 times x minus 2 in parentheses squared plus 10. That's our vertex form now. Now, in order to get something from vertex form into y equals ax squared plus bx plus c, which is, I'm just going to draw an arrow to this one. That's standard form. So if you want to get from vertex to standard form, both equations, by the way, have y equals on the left. So the only thing we need to do to get from vertex into standard form is expand everything on the right side. So what we have to do is expand x minus 2 squared. So we have to use FOIL here. And then we have to distribute after that. So just real quick, off to the side, I'm going to take this right here, x minus 2 squared. I'm just going to do that over here real quick. And then we're going to finish it up the rest of it underneath here. So x minus 2 squared is equal to x minus 2 times x minus 2. Everybody okay with that? When you square something, you multiply it by itself. Now I'm trying to remember if we did this in chapter 1 or not. Did we use FOIL in chapter 1? Did we? Okay. All right. So for here, we need to FOIL. FOIL means first, outer, inner, last. That's the order that you got to multiply your terms in each of these two binomials together. So that's going to be, that'll be x times x, right? First, x times x would be x squared. Outer would be x times -2, so that would be -2x or minus 2x. Inner, -2 times x would be another negative or minus 2x. And then last is -2 times -2, which is +4. The first, outer, inner, last for FOIL. The two terms in the middle, -2 and -2, those can go together to make -4x. So that'll be x squared minus 4x plus 4. And so what we're going to end up writing is we're going to put this back in place of x minus 2 squared because we've expanded it out into this by multiplying. So this will be y equals -3/2 times x squared minus 4x plus 4, and then plus 10. So we got two more things we need to do. We have to distribute and then add 10. So when we distribute, that'll be y equals -3/2x squared, because nothing to multiply it by there except for x squared. And then we got to do -3/2 times -4. So -3/2 times -4. Use your calculator or mental math or whatever. Let me know what it is. -3/2 times -4. Do you want a reminder on quick multiplication with this stuff? If you take your numerator and you multiply it by the whole number, divide by 2, 6. So plus 6x. Which would make this one on the end -6. And then plus 10. And then the last thing we need to do is just add a -6 and a +10, which is +4. So that'll give us y equals -3/2x squared plus 6x plus 4. And that is the answer to that. And if you ever want to double check whether you're right or wrong, just type that into a graphing calculator or the Desmos graphing calculator. See if it matches up with the graph. That's a really easy way to figure out if you got the right answer. Okay. That's it for that one. So it's the same thing as the previous question, except we did a little bit more multiplication and combining like terms after that. The last one here. This is what we did a lot of, by the way, in chapter 1. This last part says, what is the equation of j? So it's saying like j of x. Write the equation in vertex form and in what we just did as well. So we got to use that one more time. So it says, let j be a quadratic function whose graph is a translation 2 units right and 5 units down of the graph of the parent function f of x equals x squared. Now remember, if you're going left or right, that's the value of h. If you're going up and down, that's the value of k, which talks about your vertex. Is there anything about stretching or shrinking or vertical translations or vertical reflections here? Is there any information about vertical stretches or reflections on this one? On A? I don't see anything. I just see shifts. So HK, if we're going 2 units to the right, right is a positive shift, right? So that means that H is 2 and K is -5 because it's going down 5. So the vertex is at 2, -5. So we can we can say y equals, nothing in here at all talks about A. So that means A is 1. So we just write A equals 1, which means there's no number on the outside of the parentheses. So we're just going to do parentheses, and we're going to say x minus 2 squared, and then minus 5. That's the function in vertex form. And the nice thing about this particular one is that we've already multiplied out x minus 2 squared because it happened in the previous example. So we can go ahead and write y equals x squared minus 4x plus 4 plus 5. We already multiplied out x minus 2 squared in the last problem. It's right here. So we use that same thing that we just did. And so the last thing we need to do is, minus 5, not plus 5. 4 minus 5 is -1. And so that'll give us y equals x squared minus 4x minus 1. So the two forms that we needed to write in, vertex form and standard form, are right there. Now the last one has a little bit more to do, and we'll be done after that, and I'll get you your assignment. There are some like wrap-up questions on the back, but we don't need to worry about that because they're kind of assignment type questions. I'll show you what the assignment is in a minute too. So this last one, I'm just going to go ahead and write it in vertex form. We're not going to worry about converting it, even though that would be necessary if it was an assignment. So let's see, reflection of the parent function. Okay. There's no stretch or shrink. So A is -1. Followed by a translation of 1 unit down. So it's not going left or right at all, which means that H is 0 and K is -1. So if we plug in, if we have y equals a times x minus h squared plus k, if we plug those in, we're going to get y equals -1 times x minus 0 squared minus 1. Now the quicker way, or I guess more compact way to write that would just be y equals -1x squared minus 1. Or -x squared minus 1, which actually is, so here's our vertex form, and then just simplifying it, that automatically puts it into standard form, so we didn't really have a lot of work to do on that one. Okay. That is it for your notes.